All right. Hey, welcome to week 8 of the 8-week meteorology course. It happens to be February of 2013, but I believe this video probably can apply to as long as we're doing the thunderstorm conditions identification assignment in the 8-week meteorology course. So this is just going to be a quick and dirty video to help support interpreting that assignment. That assignment's kind of the keystone of all the building blocks beforehand, and so you're asked to take some concepts from all the previous map assignments and put them together and try to diagnose where you may expect storms on a given day. And to be honest, for me, for my class, it's not important whether you get the actual diagnosis of the area right. It's how you apply the logic that really counts. And if this is the old ingredients-based system for severe weather. We talked about that in previous videos. We talked about it earlier in the course. And that there's basically kind of 3+1 ingredients for severe weather, and those are sufficient moisture, instability, a lifting mechanism or a triggering mechanism, a boundary basically. And one thing that this assignment doesn't get into is shear. Shear is an additional factor that can create high-end severe weather. So for this assignment, we're not going to worry about shear. We're going to focus on those first three ingredients. Moisture, that's as simple as dew points in the low to mid 50s or higher. You just look at a dew point map, and everywhere where dew points are around or greater than the low to mid 50s, that's enough moisture to support severe weather. So that's an easy one. Find the dew point map from that assignment. Look for the numbers that are big enough to support severe weather. That means there's enough moisture in the air to fuel large thunderstorms or severe thunderstorms. That's easy. The lifting mechanism, so that's M-I-L and then S for shear. So M is for moisture. I is for instability. We'll come back to that. And then L is for a lifting mechanism or a trigger, and that's simply a front or a boundary, somewhere where winds are coming together. So if you have northerly winds here and southwesterly winds here, when winds come together, they can't go into the ground, they got nowhere to go but up. So that is a nice focusing mechanism that triggers the storm. Look for a boundary. That can be a boundary in the wind field, that can be a boundary in the temperature field, it can be a boundary in the dew point field, or it could be a boundary in all of the above. So basically, moisture is the fuel, the boundary is the trigger. And what you're going to do is look at the surface map for that. So the surface dew point, the low-level dew points, and the surface features to find boundaries. That's going to be your low-level moisture and your low-level triggers to initiate and sustain severe weather. The other ingredient is instability, and to be honest, meteorology students, people that pursue meteorology degrees, take several dynamics and thermodynamics courses to really understand the intricacies of instability. But basically what instability means is the atmosphere in a mood or in an arrangement or in a configuration to support sustained and powerful updrafts. There's a million different ways to slice it, but fundamentally, thermodynamic instability means you have warm, moist air at the surface, which is light and buoyant, and relatively cold and dense air aloft. And when you take that warm, moist air at the surface and you lift it into cold, dense air, that warm, moist air is a bubble that is still buoyant, and it will continue to accelerate upward. That's your thunderstorm updraft. That's what sustains raindrops and hailstones and basically produces all the weather. So instability is diagnosed for the purposes of this class using the 500 millibar chart. So in that assignment, find the 500 millibar chart, and there's several different flavors out there on the internet, but they'll almost all have contours on them like this. So this is a 500 millibar chart. This is February 24th, 2013. Right now there is a righteous blizzard in Kansas and Oklahoma, just rocking their world. So there's a little bit that shows up in here. So these are the pressure contours or the height contours quote unquote halfway up into the atmosphere at 500 millibars. And what that can tell you is the atmosphere arranged in a way vertically to support severe weather or rising motion to support precipitation. So where you see these contours dip to the south, like right here, that is a trough. It's not dramatic, it's not huge, but that is a trough. And a trough, an approaching trough, a trough to the west, if you're along into the east of the trough axis, you are in a relatively unstable environment. All else being equal, there's a bazillion different things that can go wrong. But the rule of thumb is if you're along, and especially east of the trough axis by a few hundred miles, you are in a regime where the upper level atmosphere is going to support severe weather as that trough rotates through. The approach of that trough has several thermodynamic and dynamic factors that will come together in general to support rising motion and severe weather. So I'm going to draw some lines on this chart to show the position of a few troughs or trough-like features, short waves. There's a billion different names to them. So I am drawing a trough axis here, and I'm drawing one in the west. And there's a big low pressure system. I think those are the good ones here. So again, apologies for the low tech nature of my attic. One of these days we'll be able to buy a cool studio for meteorology. But till then, it's my daughter's trampoline and the fan, and I apologize for the background. We are definitely a low rent establishment here. Anyway, okay, so let me fold this so y'all can see it a little better. So again, this is probably easier this way. Okay, so this is the US of A. If you can see a green line stretching right here, that is drawn along a trough axis. You see the U shape in the upper air contours. That is essentially representing a tongue of cold air beneath it, but areas along and to the east of that trough axis, if the stuff on the ground is there, the upper level atmosphere is supporting rising motion. In this case, it's supporting a pretty active blizzard underneath there. There's a big low pressure area over the Great Lakes. Again, that's storminess anywhere there's an upper level low or an upper level trough. As that low, especially as it approaches, that's going to support disturbed weather beneath it. There's also a trough-like feature over here in the west that I've drawn, basically up this line right here. You can see all of those contours have that U-shaped dip. Conversely, on this particular map, there is a ridge in the Rockies, over the Rockies. There's a big ridge out here over the Atlantic. That's where it's an upside down U shape, indicating kind of a push of higher pressures or higher heights at 500 millibar. Essentially, 95 times out of 100, when you see this feature with the U shape, where lower heights are extending southward, that is indicative of a trough. And again, along and to the east of that trough axis, in general, is going to support severe weather. If the stuff below is also going to support severe weather, you need all the ingredients. You need moisture, you need instability, and you need a triggering mechanism. You need all three of those to get thunderstorms to occur. You can't have severe weather without some part of all three of those. And like any recipe for bad news, the more of any one of those single ingredients, the more badass the severe weather is going to be. If you're really moist and you're really unstable and you have a sharp boundary and you have big time shear, those are the ingredients for really big severe weather outbreaks. If you have a strong boundary and you have significant moisture but the instability is kind of so-so, that's going to, in most cases, kind of limit the violence of the outcome. Anyway, so I went too far on that, but I would basically come back to that mapping assignment. Again, it does not have to be, you do not have to nail down to the county where you're going to see severe weather. But I would recommend that you find those troughs on the map and realize that along into the east of those trough axes, where you see that V-shape diving down, that's going to be a preferred area for rising motion and therefore severe weather. Find where there's enough moisture and it's under the influence of an approaching trough and there's a boundary evident in the wind or the moisture or the temperature fields. And if there's common ground between all three of those, then you can say there's a favorable location for severe weather. In the real world, it is obviously more complicated than this. There's a lot of details that can go wrong or flip the other way. But it's not a bad approach, and especially if you're in the emergency management field. Looking a couple days out ahead, looking and seeing those features, especially if they're discussed in the Weather Service forecast discussion. If they say, well, we're going to have a lot of moisture in place and we see all this instability, the real key is going to be, where do the boundaries set up to start this kind of these storms to fire. Well, that's something you can track. If you let them do the hard work of determining where the instability is going to be, and you track the moisture and the boundaries, you're a step ahead of the game. You can follow along with them and anticipate maybe where the action is going to be during a given day, or at the very least you can follow along with their forecast discussions and begin to say, okay, yeah, it's not that hard. There's basically ingredients coming together. That's it for this week 8. It's been a wonderful semester for the folks that are ending in late February 2013. I've really appreciated your time, and the support that you've given each other has been really special and fun to watch. And I hope we get a chance to actually run into each other someday. Until then, please stay safe, especially those of you on active duty. And thanks for all you've done this semester, and keep learning and graduate soon, and congratulations. Bye-bye.